So in this workshop, we're going to be looking at the fundamentals of AI to get a background knowledge on it. We're going to look at real data sets, and we're going to look at RoboFlow's cloud training platform. Today's agenda involves the fundamentals, why building AI is a challenge, why RoboFlow is useful for this, how to pick your own data set, and how to train your own model. You will walk away from here understanding AI a little better if you have no experience from it. This is a very introductory workshop. We're going to teach you how to choose a good data set and how to train a model on cloud. For the AI fundamentals, we have AI, which is the broad topic of the concept. We have machine learning, which is a little bit more specific, and deep learning, that is even more specific. AI, it basically looks like this. So machine learning is algorithms that are exposed to data and they perform better over time. Maybe like a tri-tree, if you guys have heard of that. For deep learning, that is another subset of artificial intelligence and machine learning. Where you feed a model a lot of data so it starts learning patterns over time. So what is AI? Does anyone know what AI here is, like the definition? Well, yeah, that's what it stands for. But like more like the formal definition of AI. Something like that. AI is the ability of a machine to simulate critical thinking, definition by IBM. So machine learning, a subset of AI, think of it as a tri-tree. It is feature extraction. You give words to a tri-tree and you extract features like the words, the letters that are in the word, and it marks the nodes, right? That's basically all that machine learning is. Model that extracts the features that you tell it to. And then for deep learning, it's a little bit more complicated. It's the field of mathematicians. It's a mathematical model where when you feed it a lot of images, it starts learning patterns to make its own definitions. The model families of AI are black box models, some LLMs, like let's see, maybe you don't know them, but Elmo is an LLM like ChatGPT that basically you don't know what's happening inside the black box. It's just so complicated, and the model, it has so many weights and so many things. You really don't know what's happening in there. We have white boxes like the tri-trees. We know what's happening in a tri-tree. We have bounds, we have runtimes, we have everything for a tri-tree. We know what's up with those. But with gray boxes, they have a little bit of both. A mathematical model that is bounded by physics would be an example of that. The four pillars of a mathematical model learning is supervised learning, where it learns from labeled data, which is mostly what we're going to see today for computer vision, bounding boxes on an object. We have reinforcement learning, where you try something again and again, like when you play Elden Ring and you lose to a boss 20 times and then you get better. That's basically what reinforcement learning is. Unsupervised learning, you give a model a lot of data and it finds a hidden structure and it labels that structure as something. And then we have self-supervised learning. In this, so LLMs actually use this where there is an answer to the learning pattern, and you make the model guess what the answer is, then you grade it, and then you show it the right answer. That's self-supervised learning. Any questions so far? Awesome. So why building AI is hard? The big wall of AI, why we can't just start making AI to fix every problem, is massive data sets. You need a lot of data for modern AI, especially deep learning models. Expensive hardwares. As you guys know, there's RAM shortages, there's GPU shortages. You can't even buy a gaming laptop because everything is being used for AI data centers. Complex pipelines. Building an AI model is so complex in a computer that most big companies have to hire a whole team of specialists to build something. So here's a video that I really like that really encapsulates why AI is a problem and why it's such a hassle. Oh, what's up? Can you guys hear that? All right, we'll just use my laptop speakers. Sorry about that. If I told you, if I told you, then so yeah, that's basically how it goes. To train an AI model, you need to hire a lot of people to find a lot of pictures and then put bounding boxes, annotated what it is, and then make it understandable for the computer. Mind you, when you do a binding box, you need to do it by pixels. So there are some bounding box editors out there that do it for you, but yeah, it's pretty complicated. You need a lot of people to train a model. This is what they usually look like. For example, for cars, they needed thousands of pictures of cars, for people, for trains, different things. And well, it's very difficult because you need servers to train your model. First of all, you need to write your kernels, which is the training pipeline. Um, I don't even know how to do that. Debugging data pipelines. Once you get an error, you need to debug it, right? You don't want to do that. We hate debugging. But with innovation, we can just find the problem, design creative solutions, and deploy models faster, which is what we're going to learn how to do here. RoboFlow to the rescue. What it does is it has a library with data sets. It's open source. You can find many data sets. There's billions of pictures there. You can put your own even. Label Studio editors for bounding boxes, which not really, but kind of solves the problem with bounding boxes. It augments the images that are already there or that you put there with AI. And there is cloud training, meaning you don't need a GPU, you don't need to pay. Everything is done on the web browser. Or you can also deploy it. Picking your data set, to pick your data set, avoid scarce data, less than 50 images in a class. Class is basically like people. You want more than 50 images of people to train the model. You want proper annotations, proper labelings. You want to make sure that the bounding box is actually hitting the person most of the time. Just make a quick look on them. And make sure that all the images are not from the same angle, because if you want to make a model to detect a MacBook, if you just keep taking the same picture of the MacBook at the same angle, then you beat the purpose of training the model. And yeah, you guys get the idea, right? Um, so yeah, let's go to RoboFlow. If you guys want to get to RoboFlow. The first step would be making an account. It's free, so that's pretty nice. This is the laptop. Doesn't like it. Yeah, see if it works. If you put it back there. Let's see if mine loads. With this I know. All right, there we go. We're having some problems with the display. So once you guys have made your accounts, are you guys following, the ones following along? Have you made your account, everyone? Any questions, problems? No? Perfect. So as soon as you make your account, you go to the left sidebar to explore. And then in here, you can look anything up. Think of a model you want to build that you want to detect, say, money, like US dollars, or I don't know, people. Just look it up and you'll find a data set for sure. So let's look project gates. No, gates. And make sure you look at how many images each data set has. Try to get more than 500 images. Training a model on just 100 or 200 images is a waste of time. This one looks pretty good. Have you guys chosen what you want to train yet? Are you guys with your data set, a big data set? Anyone have questions? All right. So if you scroll down, you'll find the images in there. And go to see more. And if you go to see more, you can see all of the images. Try to make sure that they're not very similar. For example, we have some hand drawn, we have some computer made, we have some close-ups, some blurry, some good quality. That's all good. We have that diversity of different types of images. You want to find that in your data set as well. Oh, those are different data sets. Okay. Oh, here's the what? Okay, this is the this yesterday? And then that's it. Yeah. Mhm. Where's this data? Okay. Once you choose your data set, you're gonna want to fork it. What RoboFlow is, it's a cloud computer that they give you when you make an account. It has a GPU, so you can train your own model in it for free. And once you fork a data set, you're basically copying it into your cloud computer of RoboFlow. Oh, from birth. Yeah. No. So for the model architecture, we're gonna use the most mainstream one, which is Yellow 26. That's um that's the most known one. These other ones are made by RoboFlow, so they're not as known or open source. So just click on that one, the Yellow 26. And then we can leave everything else the same, continue. And then you can scroll all the way to the bottom and click start training. You go to fork dataset, and then you fork it. You wait for it to be forked. And then, are you doing it right now? Did you choose your dataset? I have to choose like a random set. No, like these are datasets. So go down. This is a good one. Oh shoot, it's touch. Use this dataset. Oh, this one's fine. Fork dataset. Yeah. Oh, you didn't make an account. We're gonna make an account. Oh, did you sign in? I signed in with yeah. Hmm. There we go. Hold on. Can you make it smaller too? And there we go. It is as simple as that to start training your own model on a cloud platform for free. Nowadays, since everyone wants to use AI, it's becoming more open source and simple for people. And yeah, now you can just train it at home in your normal laptop, no GPU, no nothing, just like that. Anyone working on it? Any questions? Once it's trained, the model is going to be able to detect logic gates and tell you which gate it is. What is it? That's the total images. How many classes? Huh. Oh, I guess that's more in the dataset info. Oh, 6, 7, 7 classes. But it doesn't say what each means. Overview? Maybe the training thing. Okay. So for the training, we have box loss, class loss, and object loss. The goal here is to get it as low as possible. When you're training an AI model, this will automatically give you the best model, meaning the one where it was lowest for all three. Box loss is how many logic gates were in the picture that the model missed. The class loss is how many were misidentified. If it saw a not and it made it and it thought it was an and. Object loss is I don't remember. You know what up here? But yeah, the model performance is shown over there. Just a tip, you don't want your model performance to go all the way to 100 because that means that your model is not actually learning. It's learning, it's memorizing the data set that you gave it. So that means that it's looking at all that data, and if it looks at new data, it's not going to be able to label it. You want it to stay at like 95 to 97, or yeah, above 93 range, but not 100, because that means the model is bad. So yeah, that's all you got to do, and now it's training pretty nicely. And then for deploying the model, it's going to take a few hours to train the data set. Yeah, let's see if it works. Oh, trying to find something. So once it is done training on your laptop, after it's fully done, it'll let you know when it's done. And you can go to versions, scroll a little bit down, and you'll find this QR code. You can just scan it and it will run on the app, on the website, and you'll see it on your computer. So it'll be cloud running on the computer and in your browser. If it loads. And that is about it. Now you can see the model running on my phone from the website RoboFlow. It's the one I just trained, detecting people. Yeah. No, that's the a people detection one that I showed, but it's running from my phone. Yeah. No, no, pretty bad model. I did use the RoboFlow learning model that they made. I didn't use YOLO. So yeah, it's not very great. I don't recommend it. Yes. No, everything happens in the cloud and they'll send you an email when it's done. Like they'll let you it'll say in there like you want us to send you an email when it's done training and it'll automatically send you the best model, the one with the lowest loss and the best performance. So yeah, it's pretty useful, I think. And if you want to do it yourself, you can also just copy those data sets from RoboFlow. Yeah, that's it, guys. Any other questions? Very easy, very simple. I hope you guys liked it.